Hello everybody, welcome to today's maths lesson, your final one of the week, where we're going to be looking at using number sequences with a particular focus on fractions in those number sequences. So if you want to begin by getting your noggins warmed up, a little bit of an arithmetic starter for you, please. Have a go, pause me, and then I'll reveal the answers. Okie dokie, so here we go. Hopefully you slammed it to the left for 100 times 292. I could barely talk there. And there we go. There are the answers to that. It may well be that for number 3, you expressed your answer as 441 and 4/7. If you did, that's completely correct as well. All right. So, like I said, today is all about number sequences. Okay. And it's about counting forwards and backwards in fractions. Now, a couple of things that are going to help us here. Number 1 is knowing how many of each fraction is equivalent to a whole. So, for example, if I had 1/4, how many quarters are the same as a whole? Hopefully you've remembered it's when we have the numerator and the denominator the same. So, for example, 4/4. If I had something in 4, I cut it in. If I cut something into 4 and had all 4 of those parts, I would have the whole. Okay, so let's start with a simple one. I've got, can I start at 0 and count up in steps of a quarter? So I'm adding a quarter each time. So first things first, 0 would be 1/4 would be the next step. Yeah? What if I added another quarter? 2/4. Simple, yeah? So 1/4, 2/4. You're going to have to forgive my very dodgy writing on this. 3/4. Now the next bit, if I added another quarter, what would I get? It would be 4/4. I could either write this as 4/4 or I could just write it as one whole, couldn't I? Yeah? So 1/4, 2/4, 3/4, 1. What if I added on another quarter? I'm going to have 1 and 1/4. If I wanted to write that as an improper fraction, what would it be? 1 times 4 is 4. Add the 1, it'd be 5/4. Okay? Then I could go up to 1 and 2/4. Another thing with this one, guys, instead of writing 2/4 here and here, what can I write instead? What can I simplify that to? 2/4 is the same as a half, so I could go to a half instead, couldn't I? So 1/4, a half, 3/4, 1, 1 1/4, 1 1/2, 1 3/4, 2, 2 1/4. Something that might be really useful for this is drawing out the same way that you did earlier in the week, drawing out what 1 2/4 would look like, and then counting back and, taking one off each time or adding one up, whatever works. Okay, so for this next one, it's asked to start at 4 and count down in steps of a third. So a couple of things here. Firstly, we're counting down, which can often be a little bit trickier anyway, I think. And also we're starting with a whole number, which again, taking thirds away from a whole number to me seems quite tricky. So do you think there's anything we could do to make it a bit easier? Well, what about if we turned 4? We used our knowledge. I mentioned about kind of knowing how many fractions the whole was equivalent to. What about if we turned 4 into an improper fraction rather than a whole number? So we're dealing with thirds. Again, I know that 3/3 is the same as 1. So what would 4 wholes be? 3/3 is 1 whole, so 4 wholes would be 12/3. Okay, so 12/3 there would be the same as 4. Now, if I'm taking away a third each time, if I take away a third from 12/3, well, that gives me 11/3. And then if I take away another third, the next one would be 10/3. Then 9/3, and so on. That's pretty easy, isn't it? Now, that's great. The only thing is, what if I wanted my sequence to be using whole and mixed numbers? Well, once I've done this bit, which will be nice and easy if I've just got it in thirds and I'm taking away 1 each time from the top, I can then convert them back, can't I? So if I look at 11/3 and I convert it into, I'm converting my improper fraction to a mixed number. How many groups of 3 can I make out of 11? I can make 3. I'll have 2 left over and my denominator stays the same. So it'd be 4, 3 and 2/3. This would be 3 and 1/3. What would 9/3 be equivalent to? Hopefully you got that it would be 3. Okay, 3 wholes. And then if we started at 1 and counted up in steps of 2/3, well, the next one would be easy, 1 and 2/3. What if I wanted to add 2/3 to that though? Well, it would be 1 and 4/3, but that doesn't make sense because it's you can't have a mixed number with an improper fraction. So instead, what about, again, if I turn this into an improper fraction? So 3 times 1 is 3, add 2. So this is actually 5/3. So if I added on 2/3 to that, it would be 7/3 would be the next one. Another 2/3 would be 9/3 the next one. See where I'm going with this? Yeah, 11/3, 13/3. And then again, once I've got the sequence planned out, I can then convert it back into mixed or whole numbers. All right, so 2 useful things here. Number 1, how many of that fraction make 1 whole? Number 2, can we convert to an improper to make it easier? Let's have another look at an example. So with this one, well, hopefully this one might be a bit simpler. If you have a look at my number line, what's the interval between the fractions? How much is the fractions going up by each time? And therefore, what would our missing numbers be? Why don't you pause me and see if you can have a look? Well, we can use the information we've been given. We've got 1 and 1/6, 1 and 2/6, 1 and 3/6, 1 and 4/6. Straight away, I can see a pattern that it's going up to begin with. And I can also see it's going up by 1/6 every time. So this would be 1 and 5/6, which would make the next one 1 and 6/6. But can that be right? How many is 6/6 equal to again? That's actually equal to another whole. So it would actually be 2 is the same as 1 and 6/6, isn't it? It's the same, okay? And then if we go 2 and 1/6. 2 and 2/6, so on. It would carry on, and you could carry that on forever. What about going backwards then? If this is 1 and 1/6, what would be 1/6 less? 1/6 less than that. Sorry, I'm getting my tongue tied. It would just be 1. Okay, so we can use the information that we've got to help us. Number lines also really helpful here. Okay, right. I've already mentioned then for this one that earlier on when we were going backwards and forwards in thirds, I actually found it easier to convert it into an improper fraction first. I guess the reason for that is if the denominator stays the same, which it does, then all we need to do is we can just focus on the numbers at the top, can't we? And we can put those in order. We can take away or add to know what comes next. So here I've got 2 and 6/8, 3 and 2/8, and 3. What about if I turn them all into improper fractions with a denominator of 8? So 2 times 8 is 16, add 6 would be 22/8. 3 times 8 is 24, add the 2, 26/8. And with this one, I've just got 3 on its own, but I know I'm turning it into a fraction with 8, so I'm going to do 3 times 8. 24. I haven't got any numerator to add. So, but my denominator still stays the same. So I've got 22/8, 26/8, 24/8. So if I was putting those in order, I can see that I need to swap these round. And then it goes up by 2 8s each time. Okay. Again, why don't you have a go at that bottom one for me? Pause me and see if you can work it out. All right. So that one, just from looking, I think it was going up by 2 8s each time. So to get it in the right order, it would be this way. But if you turned it into an improper fraction to help you, you'd have had, let's double check, 2 times 8 is 16, add 5, 21/8. This one would have been 16 and 7, 23/8. And this one would have been 3 times 8, 24, add the 1, 25/8. Alrighty. So turning it into an improper fraction, I think makes it a lot easier. It's an extra step, but then it makes it easier for us to spot the pattern. All right, over to you then. Let's have a little look. See, again, you can pause me. I will show you what the answers are, but you can pause me, see if you can work out what the sequence is. So what would this missing number be? What is halfway between 3/4 and 1 3/4? Can you convert this into an improper fraction to help you? And then can you have a look and see with this one as well? Pause me, have a go. Right, so hopefully you went, okay, 1 3/4 is going to be the same as 7/4. If this is 3/4, this will be 5/4 in between, or 1 1/4. Here are missing numbers. I believe it's going down. I can see, is it going down by, yeah, 1/3 each time? So 9/3 or 3, and 11/3 there. What about if we had a different denominator? So this one, I've got a sequence. I've got 5 1/2, 5 7/10, 5 9/10. Well, we had something similar earlier, didn't we? And I said, oh, well, I could change 2/4 to 1/4. What about if I tried to change my half to tenths? So if we've got a number sequence of different denominators, we need to make it so we've got the same denominator. And to do that, I'm going to go, right, I want to turn it into tenths. Remember, I've got my numerator and my denominator. I do the same to the bottom as the top. 2, if I'm turning it into 10, I'm going to be multiplying by 5. So I do the same to the bottom as the top. That will be 5 as well. 1 times 5 is 5. So actually, I've got 5 and 5/10, 5 and 7/10, 5 and 9/10. So can you guess what this one would be? 2/10 less. It's going to be 5 and 3/10. Okay. Right, I think, have I got time? Yeah, I'll just have a little look. See here, have a pause, see if you can answer this question. So who's counting correctly? They're all counting in quarters. Who's done it correctly and who's wrong and why? Pause me, have a go. Right, well, Whitney is technically correct in what she's doing. She's adding a quarter each time, but she's just given me a mixed or an improper fraction. Sorry, when we get past 4/4, she should have converted that. So she is correct, but she should have converted it. Teddy's also going correctly. We can see he's converting it as he goes. Yeah, so Teddy's changed 2/4 to a half. Eva is changing into mixed and whole numbers. She hasn't done any converting. Actually, they're all correct. I hope I didn't trick you too much with that one. So they're all correct. Whitney is kept as exactly as it is. Teddy has simplified his answers into halves, and Eva's just done it as she goes. Okay. So, final thing then, this is your fluency section. There will be some problem solving and reasoning on the website. Have a go. See if you can work out how much each sequence is being increasing by. So how much is it adding on each time? And is there a sequence that's the odd one out? And then we've got here what they think will come next in this sequence. Pause me, have a go. If you're really stuck, come along to our daily drop-in session, okay? And I will reveal the answers in just a few seconds. Okay, so this top one is adding a quarter each time. This middle one is adding a 1/6 each time. And this bottom one is also adding a quarter each time. So therefore the odd one out would be this middle one, because the other two are adding a quarter each time. With Jamie and Oliver, so if I look, we've got a bit mixed here. So yeah, there was a hint to try and make them equivalent. I would have turned them all into 8s, which would have showed me that it's going up by 4/8 every time. So if I added on 4/8 to 2 6/8, that would be 3 2/8 or 3 1/4. Because what Jamie's done is he's simplified 2 8s down to a quarter. Okay. Have a little go. If there's anything you weren't sure on there, perhaps you can try some of the other bits on the website, or like I said, come along to one of our help sessions and we'll be happy to help you out. Okay. Well done on a cracking week of maths, guys. You've absolutely smashed it. And I know there's been lots to get your head round. So I'm really proud of you. Okay. Have a lovely weekend, guys. Bye-bye.